So now that we know a little bit about polynomials, let's talk about the degree of a polynomial. Just as we started our discussion of polynomials by defining algebraic terms, we're also going to start our discussion of the degree of polynomials by talking about the degree of algebraic terms. So the degree of an algebraic term is equal to the sum of the exponents of the variables. So let's look at this first example. 3x raised to the fifth. This is an algebraic term in one variable because the only variable present is the x. We could also call this a monomial because this is a polynomial with just one single term, which is 3x to the fifth. So the degree of this algebraic term is 5 because the only variable present in this expression is an x, and the x is raised to the fifth power. So this is a degree 5 term. Let's look at the second example here, negative 24. As we learned in our previous video, this is a constant, and constants are also algebraic terms. But if you think back to our previous video, we also learned that we could write constants in a different way. We learned that any constant could be written as that constant times a variable raised to the 0 power. So if this is the case, the degree of this term will be 0 because the exponent of the variable is a 0. So all constants are just algebraic terms of degree 0. Let's take a look at this third term, 1/2 xy squared. This is an algebraic term in two variables because we have an x and a y squared. To get the degree of this term, all we have to do is add the exponents on the variables. The exponent on the variable x is an understood 1, and the exponent on the variable y is 2. 1 plus 2 is 3. So this term has a degree of 3, or this is a third degree algebraic term. And lastly, let's take a look at negative 0.75 x squared y z cubed. This is an algebraic term in three variables because we have an x, a y, and a z. The degree of this term is 6 because the exponent on the x is 2, the exponent on the y is 1, and the exponent on the z is 3, and 2 plus 1 plus 3 equals 6. So this is a 6th degree algebraic term. So now that we know how to identify the degree of an algebraic term, let's talk about how to identify the degree of a polynomial. Well, the degree of a polynomial is just the greatest degree of all of its terms. In other words, identify the degree of all the terms in a polynomial, and then pick the term with the greatest degree, and that degree is the degree of the polynomial. So for example, 3x to the fifth plus 4x to the fourth minus 3x to the third plus 7x minus 2, that's a polynomial of degree 5 because the degree of the first term is 5 and the degree of the other terms is less than 5. So that's a degree 5 polynomial. The term with the highest degree is called the leading term, and the coefficient of that leading term is called the leading coefficient. So in our example up here, the term with the highest degree is the 3x to the fifth because it's the degree 5 term. So we would call that term the leading term. And then the coefficient of that leading term, which in this case is 3, we would call that the leading coefficient. Now, it's also important to note that we write polynomials in one variable in descending order. Now, what does it mean to write it in descending order? Well, that means that we write the term with the highest degree first, as we did in our example here. We wrote the 3x to the fifth term first because that's the highest degree term. Then we write the term with the next highest degree, in this case, the 4th degree term, and so on. we go down from there. So in this example, we wrote the 5th degree term first, the 4th degree term second, the 3rd degree term third, the 1st degree term fourth, and then the 0 degree term, or the constant, last. So let's write this polynomial in descending order, state the degree of the polynomial, and then state the coefficient of the leading term. And we're given the polynomial 8x minus 3 plus 17x squared minus 4x to the 3rd power. The first thing we want to do is take a look at each one of the terms. Well, this polynomial has 1, 2, 3, 4 terms. What's the degree of the first term? The first term is 8x. The exponent on the variable is 1. So the first term has a degree of 1. The second term, minus 3, is a constant. That has a degree of 0. The third term, 17x squared, has a 2 as an exponent on our variable. So that term has a degree of 2. And the last term, negative 4x to the 3rd power, has a degree of 3 because 3 is the exponent on the variable in that term. So it looks like the highest degree term is the last one, negative 4x to the 3rd. That means that this polynomial has a degree of 3. Or another way to say that is that it's a 3rd degree polynomial. Now that we know the degree of each of the terms, let's write it in descending order. The first term would be the term with the greatest degree. So the first term is going to be negative 4x to the 3rd. The next term will be the term with the next highest degree, which would be 17x squared, and so on. So writing this polynomial in descending order, we would have negative 4x cubed plus 17x squared plus 8x minus 3. Now all we need to do is state the coefficient of the leading term. Well, remember, the leading term is the term with the highest degree. So our leading term is negative 4x to the 3rd power. And what's the coefficient of that leading term? Well, it's negative 4. So negative 4 is our leading coefficient. Now you may be asking yourself, why is it important that we know how to identify the degree of a polynomial? Well, it turns out that the degree of a polynomial tells us a lot about what the graph of that polynomial will look like. And that'll become important to us as we continue our studies in algebra and pre-calculus.